May peace be on all of you. Myself, Dr. Majid Khan, Associate Professor, Loknath Dr. J.D. Pawar College of Pharmacy, Kadwan, Nashik. Today I will teach you sympathomimic drug or adrenergic drug. After completion of this topic, the student able to learn or understand the biosynthesis of neurotransmitter, classify adrenergic drugs, explain the structure-activity relationship of adrenergic drug. Adrenergic drugs are the agents which in general mimic the responses due to stimulation of sympathetic nerve. So now let us discuss the biosynthesis of noradrenaline. Noradrenaline is the neurotransmitter of postganglionic sympathetic neuron. As a result of sympathetic nerve ending nerve stimulation, it is released from sympathetic nerve ending into synaptic cleft, where it interacts with specific presynaptic and postsynaptic adrenergic receptor. So biosynthesis of non-adrenaline start from the L-tyrosine, and it is taken biosynthesis is taken place at adrenergic and dopaminergic neuron in CNS, sympathetic neuron of ANS, and in adrenal medulla. The amino acid L-tyrosine serves as a precursor for the catecholamine. It is transported into exoplasm, where it is acted by tyrosine hydroxylase enzyme to form L-dopa. The tyrosine hydroxylase is a ferric containing enzyme that requires molecular oxygen and cofactor. Now, second step is the decarboxylation of L-dopa into dopamine by the dopa decarboxylase enzyme. The dopamine formed in cytoplasm of neuron is actively transported into storage vesicle, where it is hydroxylated by copper containing enzyme dopamine hydroxylase to give noradrenaline. Noradrenaline is formed is stored in the vesicle, and from where it is released in adrenal medulla. Non-adrenaline is converted into adrenaline, and the reaction involves transfer of methyl group from S-adenosylmethionine to non-adrenaline, and it is catalyzed by the phenylethanolamine and methyl transferase. So this reaction occurs in cytoplasm, and adrenaline is formed, transferred into storage vesicle. So it is the biosynthesis of the noradrenaline. Now, classification of adrenergic drug. So the first class is direct acting drug. These drugs act by interacting directly with adrenergic receptor. It is further classified as alpha agonist, example methoxamine, clonidine, midodrine. Beta agonist, isoprenaline, terbutaline, cortisol. Second type is indirect acting. These drugs act by releasing of neurotransmitter. Example is amphetamine. And third one is mixed acting drug. These drugs act on receptor as well as it act by releasing the neurotransmitters. Example is ephedrine. Now see the structure activity relationship of adrenergic drugs. So it is a basic structure of most of adrenergic drug, that is beta phenyl ethylamine. It is the parent structure for many of sympathomimetic drug. The manner in which phenylethylamine is substituted on meta and para position of aromatic ring on amino group, alpha and beta position of ethylamine side chain, influence not only mechanism of action but also receptor selectivity. So these are the main four positions where we can modify, that is amine group, alpha carbon, beta carbon, para and meta position of aromatic ring. Now the first point in structure activity relationship, that is substitution on NH2 group. So the presence of NH2 group in beta phenylethylamine is important for direct agonist activity. Amino group should be separated from aromatic ring by 2 carbon for optimal activity. both primary and secondary amine group found among the potent direct acting agonist, but tertiary and quaternary amine give poor direct agonist activity. In general, as the bulk of nitrogen substituent increases, alpha receptor activity decreases and beta receptor activity increases. Thus, non-adrenaline, which is effective beta receptor agonist and also potent at alpha, also potent as a alpha agonist, while adrenaline is potent at beta receptor. Isopronaline is potent at beta and beta 2 receptor but having very little affinity for alpha receptor. The nature of substituent can also affect beta 1 and beta 2 receptor selectivity. For example, coltirol, salbutamol, terbutaline are more selective for beta 2 receptor. So similarly, next point is protection from deamination by monoamine oxidase enzyme. Larger the substituent on amino group, it also protects the amino group from the deamination by MAO enzyme. For example, albuterol also have bulkier amino substituent in addition to other substituent and has effect on beta 2 receptor. Phenylephrine, which is a notable exception, which has methyl substitution on nitrogen but almost favor alpha agonist activity. Now reflection spot. What is the effect of bulky substitution on nitrogen on alpha and beta receptor activity? So you think and write down your answer. Now second point in SAR, that is alpha carbon substitution. First point, methyl or ethyl substitution on alpha carbon decreases the activity on both the receptor. Second point, increased duration of action due to protection of amino group by MAO enzyme. It also affects the receptor selectivity, that is the compound is having more activity on alpha 2 and beta 2 receptor activity as compared to alpha 1 and beta 1. For example, here alpha methyl non-adrenaline, which having the methyl group on alpha position. Next point, derivative have been prepared where the alpha substituent is incorporated into ring. For example, ramipril and hydroxyaminotetraline both possess beta stimulant activity. Third point, that is substitution on beta carbon. Always maximum compound of this category always substituted with hydroxyl group and hence it have asymmetric center. Leo isomer with R configuration is more active than dextro isomer. This is explained by 3-point attachment of the drug with receptor according to Eason-Steadman hypothesis. This interaction include binding of aromatic ring, beta hydroxyl group and amino group. The OH group on beta carbon increases the activity but decrease in central stimulant activity. So if we compare here ephedrine and amphetamine, so in case of ephedrine, hydroxyl group is there on beta carbon, but in case of amphetamine, no hydroxyl group on beta carbon. So hydroxyl group is a polar group, therefore it is more hydrophilic. So here ephedrine is more hydrophilic than the amphetamine, and we know that to cross the blood-brain barrier, the compound should be lipophilic. So here ephedrine is less crosses the blood-brain barrier, and therefore it decreases the central stimulant activity due to presence of hydroxyl group. Now next point, that is substitution on aromatic ring. For maximum activity, hydroxyl group is on third and fourth position of benzene ring. When one or both hydroxyl group is absent without other aromatic substitution, the overall potency decreases. For example, metforminol, here only one hydroxyl group is present. Next point, that is hydroxyl group at third and fifth position, that is a resorption of derivative, and with bulkier substituent nitrogen result in compound which have beta 2 receptor selective action and having longer duration of action. Example is metoprolol and terbutaline. So here there is a resorptional nucleus instead of catecholamine nucleus. Next point, compound with aromatic substituent other than hydroxyl group have adrenoreceptor activity. Example, methoxamine, albuterol. So here there is a no hydroxyl group. So here methoxyl group is there, and in case of albuterol, alcoholic group is there. So these two drugs have adrenergic activity. Thank you very much.